Hi, it's Kevin Lebates here, and today I want to talk about token vaults in Ethereum. And there is a standard for token vaults out there, as you would expect, given that it's Ethereum. It's known as EIP 4626. Now, when I've gone and looked at other articles on token vaults, they focus all on yield and investment strategies and the interface definition, and they don't actually address the underlying problem that token vaults are solving. So that's what I thought I would talk about today. And for that, we need to look at a problem that needs solving. And the problem is, what if you have an investment fund? So we'll move away from blockchain here and just use general financial terms. What if you have an investment fund that people are putting funds into over time, and that fund is used to make a profit, or it may even make a loss, and you want to work out what share of the profits or losses are to be given to the various people who have deposited funds with that pooled fund, as it were. So in the naive approach to doing this would be to have a ledger, keep track of who deposited how much when, and when they took it out, to keep track of the profits and losses over time. And then when somebody decides that they want to withdraw their stake or they want to withdraw their profits, you go and total it all up. So you loop over every single event that has happened in the ledger till you reach a final conclusion, which is, we've made this much profit over this time, you put in this percentage at this point, and therefore you are entitled to this much of the profit. Now, that works okay in a non-blockchain environment, because running a loop over all that data that may be in a spreadsheet or maybe in a database is not particularly computationally intensive. The problem is that on Ethereum, running loops is expensive, and so it would be neat to have a different mechanism that could keep track of who is due how much without having to run a loop. And that's what token vaults solve, and they do it through quite a clever mechanism. So what you have is a smart contract where people can deposit the underlying asset at any time, and then what they get in return for depositing the asset that is then going to be used by the token vault to hopefully generate yield or make a profit, what they do is they issue shares in return for depositing those assets. But, and this is the key thing, the number of shares that you are going to get is not fixed. If you are an early depositor of funds and therefore should be entitled to more of the profits that the fund makes, you get more shares. And there's a very simple formula in the reference implementations for these various 4626 token vaults that shows how you can do this. You slide down the amount of shares that are issued for later contributors to ensure that they don't get a claim on the early profits. And from what I can tell, it actually uses hyperbolic functions again in the same way that DEXs do. So it's a use of that technique just applied to a different area. So that in short is how token vaults technically work. You can find reference implementations, for example, at OpenZeppelin, I believe, and there's a couple of other ones I found out there on GitHub. It's a neat solution to what would be a complicated looping problem. By issuing these shares, you're kind of doing the accounting, you're rolling up the doing of the accounting into the activity of issuing the shares. That's doing the one calculation at the point that the shares are issued saves you from having to sum up and subtract a whole load of other transactions later on. And I love those kind of solutions in DeFi. It's what makes it so interesting and fun and, quite frankly, beautiful as far as I'm concerned. So that's today's video on token vaults. I hope you found it interesting and that it was clear enough. If it wasn't, feel free to ask me some questions in the comments below. I'm still digging into this topic a bit more myself. I think I grasp the overall concept, but I'm still exploring some of the deeper subtleties of how it works and the kind of things that can actually go wrong with it. Anyway, that's it for today. See you in the next video soon. Bye for now.